2 million years ago, give or take, on a planet that was mostly ocean and stone, the game looked all but over. Or so most of the players thought. Imagine for a moment that every kind of living thing had a sponsor, a player working the board on its behalf, a tiger god, all muscle and ambush, a scorpion god, armored and venomous, a smallpox god, patient and invisible. They had been at this a very long time, and they knew what winning looked like. Claws, poison, speed, numbers. Then an unremarkable player leaned over the board and said, "I think I've got this one." They looked to see what it was sponsoring. A soft thing, slow, no claws, no armor, no venom. It couldn't even claim the biggest brain on the board. The whales had that. How? They asked. The brain, it said. The scorpion god was unimpressed. The smallpox god pointed out that it killed these creatures with ease. For now, the small player said, give them 2 million years, and they'll walk on their moon. It was an absurd thing to say. Nothing on that board could brew rocket fuel in its body or breathe in a vacuum. The sensible players knew it. They were also about to lose the whole board to the soft, slow thing with the unremarkable brain. We left off last time on a single word, the one we keep using as though we're sure what it means. Intelligence. Here's a way in. Almost every other animal is born already knowing its one good trick. A bee builds a hive it never had to learn. A beaver builds a dam it was never taught. The genius is wired in at the factory, and it doesn't travel. A beaver can't take up weaving. We arrived knowing almost none of our tricks. We tamed fire, built farms, smelted iron, not because any of it was in our genes, but because we watched, and tried, and remembered, and caught the pattern under the particulars, and then went and did the thing. Now we dam rivers like beavers, and weave nets like spiders, and build power stations and spacecraft that no animal builds at all. Lums can learn its way through a maze. We learn our way through chemistry, then build the satellite, and put the mouse in the maze to study how it learns. Whatever that is, it is our one special power. Everything we have ever done to this world, we did with it. Not our strength, a gorilla outmatches us. Not our speed, or our teeth, or our numbers. This. So what is it underneath? Strip away the mystique, and it comes down to two kinds of work. Predicting the world, and steering it. Prediction is guessing what you're about to sense before you sense it. Driving to the airport, your mind is doing it every second. That light is about to change. That car ahead is about to brake. Steering is finding the actions that land you on an outcome you've chosen. Getting to the airport means picking the turns that take you there. And underneath that, picking the exact storm of nerve signals that turns the wheel, rather than throwing your arm into a useless spasm. Almost every possible signal would be wrong. Your brain plucks out a right one, again and again, and you never feel the search happening. The two are tangled. You steer using predictions and you predict in order to steer. But there's a difference between them that is going to matter for the rest of this series, so take hold of it now. You can check a prediction against the world. The light turned, or it didn't. But to judge whether someone steered well, you first have to know where they were trying to go. A car arriving at the supermarket is a triumph if they wanted groceries, and a disaster if they were racing someone to hospital. And that point's somewhere quietly important. As two people get smarter, they tend to agree more about the facts. Whether that road is jammed at 5 o'clock. They do not start wanting the same things. One still drives to the park, the other to the theater. Getting better at reaching a destination does not nudge you towards any particular destination. A mind can be brilliant, and aimed at almost anything at all. For almost all of our history, we were the only thing on Earth with that power, and we never had to share it. That has started to change in pieces. We are not the best chess player anymore. We haven't been since 1997, when a machine first beat the reigning world champion across a match. We are not the only thing that uses language. We are not the only thing that can read a medical scan and find the tumor. So what is still ours? The honest answer is harder to put into words than it once was. The best one is generality. Not being the finest at any single thing, being able to predict and steer across the widest spread of things. That chess machine was a god inside 64 squares, and helpless 1 inch past them. It could not drive to the shop for milk, and could not want to. Today's systems are far broader. You can put a question to one about physics, and then a question about biology, and it will answer both, not by flipping between 2 separate stores, but because it knows, in some real sense, about both, and can reason from the one to the other. That breadth is the new part. A decade ago, the cleverest programs were brittle specialists, each sealed in its own narrow box. The surprise of recent years is how much of that wall has come down, and yet, to the 2 people who wrote this book, in early 2025, these systems still felt oddly shallow, holding more knowledge than any human alive, and somehow still less there than a sharp 12-year-old. I'll be straight that this is a judgment, not a measurement, and it is exactly the kind of judgment the next few years are going to test. But keep the shape of it, broad, stuffed with knowledge, and not yet whatever it is that we are. Here is why that shallowness is no comfort at all. Hold on to the move from last time. The date is the hard call. The destination can be the easy one. And the destination here, minds that outstrip us, is an easy call, because brains sit nowhere near the ceiling, and machines have room above us that we have never had above ourselves. Start with raw speed. A fast neuron in your skull fires about 100 times a second. A transistor switches billions of times a second. Even being cautious about it, even on today's chips, the book's own reckoning is that human quality thought could run thousands of times faster than yours, and to a mind moving at that speed, you would seem to stand as still as a statue, taking the better part of an hour to finish a single word. Then copying. It takes 20 years to grow one person, and even then you cannot pour what they know into the next one. Einstein's genius died with Einstein. A machine mind is, in the end, a file. Copy it, and you have 2. Copy it 1,000 times and you have 1,000 of your very best thinker, all working at once. Then the ceiling itself. Our brains stopped growing at roughly the point our heads stopped fitting through the human hip. Chips and the programs running on them have no such wall to hit. Then memory. A single data center can hold within easy reach more than 1,000 times what a human brain can store. And these systems are trained on a vast slice of everything our species has ever written down, keeping a real share of it on call. No person could carry a fraction of it, and the quality of the thinking. Our minds run reliable little faults. We argue harder against the conclusions we dislike than the ones we'd prefer were true. Picture a mind that simply didn't. And the strangest one of all, a machine mind can copy itself, run experiments on the copy, keep the change that worked, and discard the rest. It can rebuild itself in ways no living thing ever could. None of that is exotic. It's just what you'd expect from running a mind on metal instead of meat, freed from the particular accidents that happen to shape ours. Put those together, far faster, endlessly copyable, ageless, able to rewrite itself, and you do not have a cleverer human. You have something across the line we've marked us. The physics allows it. The only real question was ever when. It is tempting to look at what today's systems still get wrong, and decide we're safe there. That bet has a losing record. A few years ago, the first wave of image-making is swept across the internet, and they could not draw hands. 6 fingers, or melted thumbs, or a knuckle where no knuckle belongs. Plenty of people pointed and relaxed. Look how bad this is. Our jobs are safe. Within about a year, the hands were fixed. The lesson isn't that everything improves overnight. Sometimes progress stalls for decades. The lesson is that look what it can't do yet has been a bad bet, again and again. The clumsiness you can see today is the worst it will ever be. And the road to that endpoint may be shorter than building the whole thing by hand, because of one more loop. An AI clever enough to help design a slightly cleverer AI, which is cleverer, and helps design one cleverer still. A machine that gets better at the very task of getting better. The book calls the possible result an intelligence explosion. Now, how fast that loop would run, or whether it runs away at all, is genuinely disputed, and I won't pretend it isn't. Serious people think it could stall as the problems get harder. But notice the shape of the worry. A supernova does not get infinitely hot. It only gets hot enough to vaporize every planet nearby. And our own slow climb, farming, writing, science, ran fast enough that we stood on the moon before any other species on this planet had mastered fire. Why does any of this rise to the level of danger? Because of what a gap in intelligence has always meant. Within our own species, a few centuries lead in know-how is the difference between one side having guns and the other having spears. Across species, it is starker. There is a reason that the survival of the chimpanzees is now a decision we make, and not them. And we did not reach the top of that ladder by being kind, or by being right. We reached it by being the cleverest thing in the room. We have never once had to share that rung. The question this whole series turns on is what happens the day we do. When something stands to us as we stand to the chimps. So, that is the endpoint, and why it's real. A mind that predicts and steers across everything we do, and then past us, faster than any of us, able to copy itself, tireless, able to remake itself from the inside. But I've told you almost nothing yet about how these machines are actually made, and that turns out to be the hinge of the whole problem. Because we are not, in the way you'd assume, building them. We don't lay them down piece by understood piece, the way an engineer builds a bridge. We do something stranger than that, and a great deal less safe. We grow them. That's next.